What's up everybody, this is Matt Brown, and today in our video we are going to be doing some RF hacking with an SDR. I recently came back from the Hardware I/O security conference in San Francisco, and I took a training on software-defined radios, something that's very new to me. And if you have taken a training like that and have experienced what I've experienced, something I always notice about myself is that if I go and learn something completely new, that knowledge decays really quickly if I don't rapidly apply it and try to keep learning in that subject area. So radio stuff is something that's really new to me. And so I took this training, learned a lot, but now I'm trying to make myself continue on and learning more and reversing radio signals and understanding how they work. So today I have my Flipper Zero here, and what some people don't know is there is actually an application that is only accessible currently, I think, from the CLI on the Flipper, where you can chat. You can chat with other Flipper Zeros that are within some range of you. And so what we're going to do today is we're going to use this software-defined radio to reverse engineer and actually do a replay of that chat signal from our Flipper Zero. So with that, we are going to switch over to my screen here and introduce you to the tool that we're going to use to be doing all this reverse engineering. This is called Universal Radio Hacker. So this is a tool that can capture signals using a SDR, a software-defined radio, and it can analyze those signals. You can decode, demodulate said radio signals, and then you can attempt to retransmit either the original signal or a modified version of the signal. So I'm going to show some of that today, some of the things I've learned, and some of the things that I'm still learning along the way. So what I have here is, so this is Universal Radio Hacker, and then over in this other terminal, let's make that a little bit bigger, I'm going to open a terminal on dev tty mc1. I already have something running on 0, and so what we're going to see here is that this is the CLI interface to my Flipper that is connected over USB to my Linux machine here. So with that, we can type help, and we can see that there is this subghz command. So I'm going to run that. And then we can see that there's a whole bunch of options here, but really what we're going to be focused on today is the chat application. So all we have to do is type subghz chat, and then we are dropped into this kind of like subshell, this program that's a chat program, and it says that we're receiving at frequency 433 megahertz, and then we can type messages, and if someone else had a Flipper in the vicinity of my Flipper, and they were also running this program, they would see in their terminal that message identified by my Flipper Zero's name, and then you could talk back and forth. So what we're going to do is we're going to try to analyze this radio signal in Universal Radio Hacker. So we already have the first piece of information. It's kind of given away here, the frequency. So we have to know what radio frequency this signal is being transmitted on. So let's go over to Universal Radio Hacker. And under File here, this is where a lot of these kind of sub-tools, these really important tools that come with Universal Radio Hacker that are not on this main window, are here under File. And so first what we're going to do is we're going to look at the spectrum analyzer. So the spectrum analyzer is going to look at the radio spectrum, right? So on the left side of this graph will be lower frequencies, and then on the right will be higher frequencies. And so this is going to allow us to see that we are in fact receiving a radio signal on the expected frequency. So we have our Pluto SDR. This was provided for us in the training that I took. It's kind of a mid-range SDR. It's something that can be provided for in a class. It can receive and transmit so that's very useful. But it's not something like a Blade RF or a USRP. It's kind of there in that middle range. And then we need the device identifier, and sometimes you can get lucky and you can hit this button, but on my computer I have some kind of Wi-Fi card and that's the only thing that it sees. So we need to get this device identifier of my my SDR, my Pluto SDR. So to do that, there's this command called ioinfo-s, and that is going to give us this device here, which all I need is this USB identifier. And then we can come up here, get rid of this nonsense, and put that in for the device identifier. So here we have the frequency that we're going to start with as our center frequency. Again, we kind of saw, we already really know what frequency it's going to be transmitting at because we could see it in the terminal on the flipper 0, but we're just going to demonstrate the spectrum analyzer here. And then the gain, I'm going to set it to 60. You're going to really have to play with this depending on how far away you are from the device that you're picking up, how good the antenna is. These antennas are nothing to write home about that I have on this SDR. They were provided with the Pluto SDR. So we're going to start, and we're going to see that we have a bunch of data coming in from across the radio spectrum. And so now what we're going to do is we're going to switch over here, and I'm just going to type something, and then you will see that it has recorded that it's received a bunch of radio transmission right around this area. So our center frequency looks good, 433.92 megahertz. And we can see that there is actually like a wide range here of frequencies that are being used. And so what that is going to be a hint of, and this is where I am still learning in the realm of RF and software-defined radios, but this eliminates there are different ways that you can transmit data over a radio. You can either do it by increasing and decreasing the power output of your radio. That's called amplitude modulation. Or there's frequency modulation, where you can use different frequencies to transmit different data, 1, 0, things like that. This is super high level, and feel free to correct me in the comments all the mistakes I'm going to make. I'm going to show you at the end of this video where I'm currently hitting my head against the wall with this device, so stay tuned for that. But we can see that this is probably going to be FM. This is probably going to be frequency, not modulation. That's the wrong word. But anyway, so we can stop this. Don't need to do spectrum analyzer anymore because we are now going to record this signal. So I have the same parameters, and I have to paste this stupid device identifier in here again, and we're going to hit start. And now I'm going to come over here and I'll say hello world, and so we can hit stop, and you can see here that we clearly received a transmission in this area when I went and typed that command. So we're on the right track, right? But there's also all this noise here, and we'll talk about some of the ways that we can distinguish the signal from the noise. A lot of that, like if you have the gain set too low, you won't get a big distinction between those two. If you have the gain set too high, then you also have problems, right? So you kind of got to find the sweet spot there. So I'm going to go ahead and save this capture here, and I'm just going to call this, flipper. We'll just call it flipper 1. And so now up here in our main window in Universal Radio Hacker, we have that file over here, and we can just drag it into this interpretation window. So from this window, this is where we start to do all of our work reverse engineering this signal. So there's another thing I can do to, I was right when I said modulation. So frequency shift key modulation, FSK. So that's my hypothesis, which obviously I already know because I've prepared for this video just a little bit. So this is going to be our modulation instead of something like ASCII. And then again, I'm learning in the radio realm, just determining if something is PSK is a little bit more fuzzy to me. But there are ways that you can determine that. So we're going to set the modulation type to FSK here when we start to decode the signal. But what we can do, even without messing with this at all, is what I can do is a replay attack. So I'm going to attempt to just retransmit this same exact signal, and we're going to see it be received by my flipper. So over here on my flipper, I'm just going to, make some space so we know that it's not my old message that I sent. So we're going to attempt to replay this hello world message that we captured with our software-defined radio. And so all we're going to do there is that we're going to hit this play button next to our signal, and that's going to pull up another window that we then paste that device identifier into again. Our frequency already set correctly. All these settings are fine. Here the gain is like 0 versus, removing signal strength. So we just want to replay it as is. And so this is actually going to infinitely repeat this signal. So we should see hello world get spammed. So we're going to hit that. I'm going to come over here. And it's not working. Oh, hey, we got one. There we go. So some of this is going to probably matter how I angle. Yep, there we go. Another one went through. Like I said, these antennas, nothing to write home about. Maybe they're too close together. But as you can see, I've transmitted this. Oh, it's just really slow. Oh, right, because we didn't cut down any of the noise. So this actually looks like it's working just fine. Okay, so current sample, we send it 6 times. Okay, 5 or 6 times. Yeah, okay, so that worked just fine. So that is the simplest version of a replay attack that you could perform on some sort of radio protocol, right? I've literally just captured the raw message received by my SDR on a certain frequency, and then I just replay it back into the air. And then my flipper interprets that as a different flipper transmitting that message to it, and it, outputs it on screen. So there we have successfully performed our replay attack. Now, though, I want to actually start to decode this protocol and see what it looks like under the hood in Universal Radio Hacker. So we're going to get rid of this send screen here. Okay, so here in the interpretation tab, there are a lot of things we can do in Universal Radio Hacker to clean things up. So the first thing we're going to do is we're going to look at this spectrogram view of our signal. And this is another way that we can tell that this is using frequency shift keying instead of something like ASCII. And the reason is, so this graph on the y-axis has frequency. So this is a hard graph for my brain to understand when I first looked at this. So we have the time domain on the bottom, and then on again on the y domain we have frequency differences. And so if it was just transmitting only on one very tight frequency, you would see the line be very flat. But because it has some width to it, that's another hint that this is a frequency modulation. And so what we can do is, there's actually a cool thing we can do. We can go like this. We can select where we think the frequency is supposed to be within, and then we can apply what's called a bandpass filter. And then this is going to filter out just noise that in that other screen, when we're looking at the spectrum analyzer, any of the junk to the left or to the right of our core signal, we're going to get rid of all that noise. And so we're going to say apply bandpass filter, and then it's going to create kind of a new signal down below here where it's going to have a refined view of what's going on. Then what we're going to do is, so I mentioned there's all this, because I hit record and then it took me a while to switch over to the other screen. That's why we have all this just empty nothing on the left side and on the right side of the signal. So we can actually go ahead and zoom in on the signal and just kind of take, highlight a chunk of it. And then we can say create signal from selection. So we're just creating another subset of the signal that is, we're just kind of zooming in on what we care about inside of this radio transmission. So now the other thing we can do to clean up this signal is there's literally this filter button that you just keep pressing a bunch of times, and it does some magic math that cleans up any errors, some errors in the radio transmission. So I hit that a couple times, and now we're going to come in here, and now we're going to actually try to set all of these settings, these magical settings here, for demodulating the signal correctly. And so we're just going to hit this auto detect parameters, and it's just going to do some magic. So that's kind of cool. And we can see right away here. Okay, so I have this bit stream here. So it thinks that this is the binary data that our signal is transmitting over the air. And so now Universal Radio Hacker actually helps you out in a lot of ways here, but I want to show you what I could do just with this. If I was given this bit stream, what it would look like if I started to analyze it. So I'm gonna pull up CyberChef here, and I'm just gonna paste this in to the input field here, and then I'm gonna say from binary. And so here I'm converting from binary, and here we just have a text representation. Our hello world message is nowhere to be seen in this. But so this is interpreting these bits. It's converting it to an 8-bit ASCII, right? Because here we have, byte length 8. But what if our radio signal is just a little bit off in where we're starting to interpret data just from noise, right? So what we can do here is in CyberChef, we can just go to the front of our binary message and just hit delete one bit at a time, just deleting bits off the front of the message, and observe the output. And if some obvious ASCII text just appears, then we probably know where the right offset is. And so I'm going to do that right now, and it's going to happen really fast. So I hit that, and okay, I removed that first bit. Now all of a sudden we can see our hello world message. We can see the name of my flipper, right? And these are, if you're familiar with this is Unix terminal color codes. So that's how it's actually transmitting the color of the terminal text and what it should be. So here we can see that, okay, so our original message that had that 1 in front of it, that's probably just some kind of a start bit, or we just need to ignore that, right? So now if we jump back in here, we will see, because here in Universal Radio Hacker, it just kind of ignores that first bit. I think that's because we have this error tolerance set. I think if I set this to 0 now, see, I'm still learning this. I don't know exactly why it just magically decodes this the ASCII correctly here and not in CyberChef. But if you know, let me know down in the comments. So now we were able to properly decode all this. But let's say we want to dig more into what this protocol might look like. Well, that's where this analysis piece comes in. So we have interpreted the signal, and we think we've interpreted it properly based on the fact that we're seeing ASCII text in our data. So now I'm going to uncheck all of these other signals and just just include that last signal that we have. And, oh, well, you can see here that I was doing that work. Okay, so this first bit, right, we kind of determined that this first bit is kind of just a throwaway garbage. It's some kind of a start bit. And so what we're going to do is we're going to say right-click, create label, and it's just going to auto-name it preamble because it's like the first thing that's there, right? So we're going to do that, and then we're going to highlight this out. And you can see as I highlight, it's interpreting the hex of these things here. And so I'm going to keep doing that until it doesn't make sense anymore. Yeah, it's just you know 1 0 1 0 1 0 1 0. So to there, and then I'm going to create another label. It calls it synchronization, right? So that way a radio receiver could just listen for, you know, the hex a 8 times. It could just listen for that signal. And once it sees that, that's how it knows to like synchronize and start the message directly after that. And so we're just going to highlight all of this to the end like that. And then we're just going to create a label. And then here we can say that this label, we're going to call this like the payload. And we can say interpret that as ASCII, and there we go. So we have somewhat interpreted this signal. Now I'm going to show you where I'm currently completely stuck. So if you can totally click off this video at this point, but what I want to be able to do in Universal Radio Hacker is modify this payload and send some sort of different message. But anytime I try to do that, I have not gotten it to successfully be received by my flipper 0. And so what theoretically I should be able to do now. So now I've got this, you know, signal completely decoded in our analysis tab. I should be able to go to this generator tab. I go edit, and so I got to set all these settings, right? So I take my original signal, and I should be able to say auto detect. And so it detects a carrier frequency, and it detects some other parameters here. And then I should be able to go and say, here is my data, and then it should modulate that data. So we demodulated, we demodulated, decoded the data. It should be able to encode, modulate that data again, and send it out at the given frequency. So here we should still have my, no, I don't have that copied anymore. We need our device identifier for our SDR. We're going to send this signal. And so this should be like retransmitting this message here, but it's not. It doesn't work. There's something wrong with my signal. If you are smarter than me with all this SDR stuff and radio waves, please hit me up in the comments or jump to our Discord server and feel free to help me out. I'll post some of the data there. But yeah, this is my real initiation into the world of RF, reversing signals. And so, again, took this training, trying to make myself learn more. Hopefully we'll have a couple other videos where I'm reversing some interesting signals. I've also been messing around with a ceiling fan of mine that has a remote control here. And you can, like, you know, remotely turn the light on and off, turn the fan speed up and down, and some interesting things there. But don't have too much more for you. Thank you for watching this video, and have a good day.